It must have just stopped. Okay, so what if we now start on the trigonometry of a right angle? Okay, so the reason we pick right angles, because let's say if we have our unit circle with our x and our y axis, let's say we decide to have some point on the graph. Okay, that could be our power 4, power 3, power 6, any one of them. Any point you pick on the graph, if you go down to the x-axis and to the origin, you will have a right triangle. If you pick a point over here, you go down into the origin, you'd have a right triangle. So any point you pick anywhere on this graph, you're going to have a right triangle. Okay, so we just use that to figure out how to solve our cosine and sine values. Okay, so let's say if we just start with the quadrant 1 right triangle. Clean that up a little bit. Okay, so let's say, because in quadrant 1, that would be your theta. So if that's our theta, we'll call this our opposite. We call this our adjacent, which just means next to. And this point across from your right angle is the hypotenuse. Okay. So if we had, let's say, if our right triangle looked like this, and instead of our theta being here, if our theta was up here, then that means this would be our adjacent because it's next to theta. This would be our opposite because it's opposite theta. Same way this one was the opposite angle. And the hypotenuse is always across from the 90-degree angle. Oh, you said opposite theta. Put that there as kind of a little identifier. Okay. So this is where it can get actually a little bit easier to remember all of those. Remember, and you probably remember this from before. SOHCAHTOA. SOHCAHTOA. And that's because sine of theta equals opposite over hypotenuse, SOH. Cosine of theta equals adjacent over hypotenuse, CAH. And tangent of theta equals opposite over adjacent, TOA. So if you remember SOHCAHTOA, you can remember all those three. Okay. Now for secant, cosecant, and cotangent, you just have to remember their reciprocals. Since cosecant theta equals 1 over sine of theta, which is just the reciprocal of theta, that means that cosecant of theta is going to equal the hypotenuse over opposite. And we know that secant of theta is 1 over cosine of theta. which is just the reciprocal of cosine. Oh, let's put sine of theta up here. There we go. Okay, so that means your secant of theta is just equal to hypotenuse over adjacent. And we know that cotangent of theta is just the reciprocal of tangent of theta. So that means cotangent of theta is just equal to adjacent over opposite. Kind of separate these a little bit. All right, so for the most part, if you remember these three you can kind of figure out in a couple of seconds. All right, so any questions on that one? All right. Okay, so let's, almost the writing. All right. So leave that up for a few seconds. All right, so let's say, for example, we want to find the exact values of the 6 trig ratios. Using this triangle. Okay, let's say if we make theta up here, we have 3, 5, and 4. Okay, so the one thing we know, well, not the one thing, the 3 things we know from looking at this triangle is that this is our theta, our side next to, oh, forgot my right angle. Our side next to our theta is our adjacent. The side opposite from theta is our opposite. And the side across from the right angle is always our hypotenuse. Okay? So if sine of theta is equal to opposite over hypotenuse, then you have 4 over 5. Our cosine of theta is equal to the adjacent over hypotenuse, which is 3 over 5. And our tangent of theta is equal to opposite over adjacent. So you have 4 over 3. Okay. Now to figure out cosecant, secant, and cotangent, we just flip, flip, flip. Okay. So cosecant of theta, remember that's hypotenuse over opposite, that's just 5 over 4. Secant of theta, we just flip our cosine, which is hypotenuse over adjacent. It's 5 over 3. And our cotangent of theta, we just flip our tangent, adjacent over opposite, which is 3 over 4. So if you have all 3 sides, you can figure out all 6 ratios. All right, so any questions on that one? All right. Okay, so let's say, for example, we want to find the values, or the exact values of the trig ratios, let's say for problem A, say sine of alpha and cosine of beta. Say for problem B, tangent of alpha and cotangent of beta. And for problem C, secant of alpha and cosecant of beta. Okay, and we're going to use the triangle here. This is our right angle. This is our angle alpha. This is our angle beta. This is 3, and this is 5. Okay, so sometimes they'll only give you 2 sides, which means you have to use the Pythagorean theorem to find the third side before you can do anything else. Pythagorean theorem to solve for the missing side. Okay, so we have a squared plus b squared equals c squared. So a squared plus b squared equals c squared. So that gives us 3 squared plus 5 squared equal this unknown c squared. So you have 25 plus 9. So c squared equals 34. So you know that c is equal to plus or minus square root of 34. We know that's not a length of negative square root of 34, so we only need the positive. Okay, so we know that side is, I'll put it in a box since we had to figure that out, square root of 34. Okay, so to find our sine and cosine, put that right there. Sine of alpha equals opposite over hypotenuse. So if this is our alpha, that's our opposite, and that's our hypotenuse. So you have 3 over square root of 34. And we won't worry about rationalizing it. Clean that up a little bit. 3 over square root of 34. Okay, if they did want you to rationalize, you just multiply both by square root of 34. Okay, and our cosine of beta, which is adjacent over hypotenuse. This is our beta, so our adjacent over hypotenuse is 3 over square root of 34 also. Okay, so what about tangent of alpha? Remember, tangent is opposite over adjacent. Okay, so your alpha, the opposite is 3, adjacent is 5. And cotangent of beta, which is just the tangent reciprocal, is adjacent over opposite. Okay, so for beta, you have adjacent over opposite, which is 3 over 5. So you kind of see how they relate to each other once you change angles. Okay, so for C, secant of alpha is equal to cosine flipped, which is hypotenuse over adjacent. Okay, so for alpha, hypotenuse over adjacent is just square root of 3 over 5. Nope, adjacent, yep. Nope, square root of 34 over 5, that's right. I don't know why I went to the opposite. And cosecant of beta, remember that's just sine flipped, so that's hypotenuse over opposite. Okay, so if we have our beta, hypotenuse over opposite is square root of 34 over 5. Okay, so you see a function in a trig function and its cofunction. When you switch the angles from this angle to this angle, you can say that they're pretty much equal. That's not something you have to remember because you can just figure it out pretty quickly. All right, so any questions on that one? All right. Okay, everyone's still writing. Oh, leave that up for a few seconds. All right. Okay, so let's say you want to find the side. Labeled X. And if they give us the right angle, they give us 30 degrees, X, and 25 for our hypotenuse. Okay, so for this one, they gave us our angle, our theta. We have to find our opposite, and we know our hypotenuse. Okay, so if we use sine of theta equals opposite over hypotenuse, and that means sine of 30 degrees equals our opposite, which is x, over 25. So if we multiply both sides by 25, that will give us x equals 25 times sine of 30 degrees. Okay. So sine of 30 degrees is 1/2. So that gives us x equals 25 times 1/2, which is just 25 over 2. So any questions on that one? Okay. So let's say if the x would have been right here. Now if the x would have been here, then you would have had your adjacent over hypotenuse. So instead of sine, you would have used cosine. So it all depends on which side is missing and where your theta is. All right, any questions on that one? Right. Let's do writing. All right. Okay, so let's say, for example, we want to sketch a triangle. Uh-oh. That has acute angles, well, has an acute angle theta, and find the other 5 trig ratios of theta if secant of theta equals 7 over 2. Okay, so basically what they're saying is if we give you this one, find the other 5. Okay, So we know that secant theta is the reciprocal of cosine theta. Secant theta equals 1 over cosine of theta. Okay. So if secant of theta equals 7 over 2, that means cosine of theta is equal to 2 over 7. Okay, which just happens to be our adjacent. Don't really need the equal sign. Adjacent over hypotenuse. Okay, so if we drew a triangle, with that is our right angle, and this is our theta, our adjacent would be 2, and our hypotenuse would be 7. Okay, so we're part of the way there. So all we have to do now is use our Pythagorean theorem to solve for that missing side. For the missing side. Okay, so that means our a squared plus b squared equals c squared. We can make that a or b, doesn't matter. So we'll let 2 squared plus b squared equals 7 squared. Subtract 2 squared from both sides, so b squared equals 7 squared minus 2 squared. Or b squared equals 49 minus 4. Square root both sides. Oh, well, I might as well finish this off. B squared equals 45. Now we square root both sides. B equals square root of 45, or 3 square root of 5. Or you can leave it as square root of 45. I don't think it would really matter in the homework, but they may want it simplified. Okay, so we found our B. And I'll just rewrite the graph instead of filling things in. Okay, so we have 2, we have 7, we have our theta, and we have our newly found 3 square root of 5. Okay, so from there we can figure out all the other identities. So we have sine, which is opposite over hypotenuse, 3 square root of 5 over 7. We have our cosine, which we really already knew because we got it from up here, but we'll do it anyway. Adjacent over hypotenuse, which is 2 over 7. Our tangent, which is opposite over adjacent, is 3 square root of 5 over 2. Our cosecant, let me separate that a little bit, make sure there's no confusion, which is the reciprocal of sine of theta. That's just 7 over 3 square root of 5. And if they want you to rationalize the denominator, multiply by square root of 5 over square root of 5, which would be 7 square root of 5 over 15. Like I said, and that's if they want you to do it. So it's either that one or that one. But for the most part, they usually don't. If they did, they'd probably specify it. At least I hope they would. Okay, so secant of theta, which is the reciprocal of cosine of theta, is just 7 over, well, actually they gave that to us, so we didn't have to figure that out. 7 over 2. And cotangent of theta, which is just the reciprocal of tangent, is 2 over 3 square root of 5. And again, if they wanted you to rationalize the denominator, that would be 2 square root of 5 over 15. All right, so any questions on that one? Okay. Okay, so let's see. Oh, let me see if anyone's still writing. I think everyone's caught up. Okay, let me get a good example here. That's a good one. I'll go with this example. Looks pretty good. Okay, so let's say if we have solve for sides A and C for this right triangle here. Say A, B, and C. Now for some of these, instead of theta being in here, they'll say this is angle A, or angle B, or angle C. That's why I want to make sure this example is a side A and side C. So this is 27 degrees, and this is 15. So sometimes they'll kind of switch up the notation a little bit. Okay, so we know that angle A equals 27 degrees, and this side is 15. So we know, well, to figure out A and C, we can do our cosine of 15 over C, or we could have done sine with opposite over C and solve from there. But we have cosine of theta equals adjacent over hypotenuse. Okay, so in this case, it would be cosine of 27 degrees equals adjacent over hypotenuse. So it's 15 over C. Okay, so if we multiply both sides by C, that would give us C times cosine of 27 degrees equals 15. Then divide by cosine of 27. C equals 15 over cosine of 27 degrees. Okay. Now on the homework, they want you to plug it into a calculator and give you the actual value. So that would give you C is equal to 16.83. Okay, so we have our C. So now we just have to solve for A. Oh, thank you.